Hey all, here we will cover a quick quiz example of Nernst potentials covered in 2020. The question is as follows. When comparing two compartments, each containing KCl and NaCl, separated by a membrane permeable equally to Na plus and Cl negative ions, but not to other ion types, find the voltage difference between the two electrodes as measured by an ideal voltmeter. Okay, so here we want to focus on the fact that the membrane is only permeable to Na plus and Cl negative, not to K plus. We also want to note that the permeability is equal between those two, so PNA and PCl can both be written simply as P. Now we want to look at the amount of sodium and chlorine ions in each compartment. Solution 1 has 20 millimoles of Cl from KCl and has 40 millimoles of Cl from NaCl, which totals to 60 millimoles per liter. Solution 1 also has sodium, but the only contribution is 40 millimoles per liter from NaCl. Do the same for the second solution. You should find that it contains 10 millimoles per liter of sodium and 660 millimoles per liter of chlorine. Since the concentration of Na plus is written as out divided by N, and we know that it has a positive valence of 1, the voltage difference should be calculated by using V2 minus V1. In other words, the electric field is measured where solution 2, the inside, is positive, and solution 1, the outside, is negative. Sodium wants to diffuse from the high area of concentration in solution 1 to the low area of concentration in solution 2. The concentration ratio should be set up such that if the valence value is positive, the high concentration is on the bottom. If the valence value is negative, as with chlorine, the concentration is high divided by low. We need to also account for the standard potential of the two electrodes. In this instance, they cancel each other out, and we are left with V2 minus V1 is equal to Vm. Now we know that we can just plug in the values for the inside and outside concentrations of each ion that is permeable. The Na ratio should be 40 divided by 60, and the ratio for chlorine should be 660 divided by 10. Now, for question B, if you remove the membrane, there should be no potential difference because the ions would diffuse and no membrane voltage would be present because there is no electron gradient from the ions. Again, the standard potentials of the electrodes cancel out. The current is then the difference between the standard potentials of the electrodes divided by the impedance of the electrodes plus the impedance of the solution. Again, the difference between the standard potentials is just 0, so the overall current should be 0 as well. Alright, that's it for now.